Henry, welcome back. It's always a pleasure to have you and StarkNet here. And yeah, to everyone, welcome. I hope you're enjoying the event so far. This is obviously the third one, and hopefully there's going to be some good building over the weekend. So let's see what Henry's got in store. Henry, over to you.
Hey, thank you. So, can we make a small show of hands? You can have a reaction emoji on Zoom. Can you tell me, did you do the tutorial? How many points did you get? Like, if you did at least one or two exercise, can you put a little heart? That will make me very happy. And if you're proud of your points, please show them in the chat. How many points did you get? Nice. So Xavier had 26 over 26. Pretty cool. I know some people, some other people told me they got 26. Nice. 26, 22, all of them. Very good. 8, good job. 8 is, you spent some time doing it, so keep at it. For sure, if you manage to get 8, you can get 8 more. And that's the objective with these tutorials. The next 2 points are always just that far away. So keep going at it, no rush, and have fun doing it. Yeah, somebody is saying, will we see NFT marketplaces on StarkNet? Will it be better than Polygon? I don't know if it will be better than Polygon. Beauty is in the eye of the beholder. So, but we do have an NFT marketplace on StarkNet already. It's called Oasis, and actually you'll get to see it today. Actually, I might mint an NFT just for fun to show you. Need to know how to debug Cairo in local, can't find the tutorial. Also, can you create the style guide? Yours and OpenZeppelin one are different. Let's have a common one that we can point and promote. Okay, so that's actually a good point. Before we start the tutorials, you're going to read some code today. I have to say the code is not up to high to the best standards of programmation right now. For these tutorials, we have optimized for legibility, right? We want to make it easy for people to grasp it without necessarily doing best practices of code. I know this is not the best way to do it, but that's how we should do it for now. And for sure, but know that some convention need to be done better than what we implemented it here, and it will get better in the coming weeks. We need to make these tutorials better. And by the way, you're always open to, you're always welcome to make a PR on the repo. It helps us a lot. So, okay, so this we covered last time. It's fine. Okay, StarkNet is cool. Now, developing on StarkNet. So far, what you've done is basically that you have you've read code, but you haven't written it, actually. Now, Cairo is a bit different than Solidity. You've seen now. It's as much a hurdle as it is an opportunity. I know some of you have clicked already. For those of you who haven't yet, it will come. But what is cool with Cairo is that it was designed to do provable program, and so it is not bounded by the EVM. I was talking with somebody earlier today and actually took this example. You can take your Solidity code and transpile it to Cairo, but when you compile your Solidity code, the compiler will automatically bound what you can do in your functions to the EVM capacity. So you can't pass more than 7 arguments or do this kind of stuff, right? And so even if you transpile from Solidity to Cairo, you will get these boundaries, even though they don't apply to Cairo. So that's a big limitation. But if you code natively in Cairo, you will get rid of all of this and you'll be able to arrange your code and design it in a much more native way. So you'll be more efficient and you will have to resort to less hacks to make things work. Now, today, you're going to be using standards implementation. So you know that if you're developing on Solidity, you have and you want to deploy an ERC20 or an ERC721, you don't really write it yourself. I mean, there's no point in writing something that was written thousands of times before, and you won't have time to audit it. You just take code that was audited and battle tested, and you reuse it, right? And you use OpenZeppelin's one. And we want people to do the same for StarkNet. The aim is not for you to re-implement these standards. You should use things that are already out there. Now, as you can see on my presentation, I put a picture of a festival that happens every year in the desert. And basically, what happens is that for a week, people show up in the desert and they build a crazy thing and they spend a lot of time. And for this week to happen, for people to actually show up and have fun, a bunch of people have spent a month in the desert before that, creating and installing the infrastructure. And we're very much at that time in space and time for StarkNet, meaning that these tutorials have not solidified yet, these standards. ERC20, ERC721, you can pick them from the OpenZeppelin repo, but they're not yet ready for production. They're still evolving. So use them with caution. I show them to you today because, I mean, you guys are hungry. You want to build on the platform that is fast and that is doing new stuff, and that's what we're offering, but it's not dry yet. The paint is not dry yet. The infrastructure is still being installed, so be mindful of that. If you want to actually implement this in your contracts, make sure that you're able to evolve them with time. Now, something important, you've seen that and you've seen that in the first exercise. Importing function is a bit different in Cairo and in Solidity. In Solidity, you can have various smart contracts in a same file. You don't have that in Cairo. So when you import a function, when you want to inherit one contract from the other, importing works a bit differently. First, when you import and you import functions, the functions are by default visible. You don't like what you would do in Solidity, you import the file and then inherit from it. Here you import function. You don't inherit from another contract. The importing pattern, and that's what you discussed earlier in the chat, is still being defined. It's not enforced by the compiler. And that's very much a feature. We discussed making it enforceable by the compiler, but the community said, no point in having something too rigid so soon. Let's let people converge onto a standard, and then if something needs to be solidified, we will, but for now, we don't need to. So right now, in general, we would differentiate between base contracts and front-end contracts. So you've seen in you have seen in by reading the code that we have internal function and external functions. Base contracts are those contracts that will implement inner workings in the smart contract and that implement only internal functions. Front-end contracts, on the other hand, will import function from internal contract and then put a wrapper to make them visible to the outside, right? So they will implement external function in these contracts. So importing in Cairo is different than in Solidity. I think you've seen it, and today you'll have to basically take some existing code and import it again and make a new code out of it. So I want you to be mindful of that. There are some questions. I'm going to read them now. So please recommend a book about Cairo. There's no book about Cairo. Sorry, it's too new. DC Builder is recommending the documentation. Yes. And eventually you will be able to use your repo, DC Builder. I know you're working on this and we want to contribute to that too. We can say that Cairo is a DSL. I'm not sure what a DSL is. Sorry. And then reinvent the wheel. What do you mean reinvent the wheel? It was earlier, maybe when I was saying something. Anyway, speaking of input, DSL, domain-specific language. Okay, understood. And I'm not sure what a DSL, domain-specific language is too. Sorry, too much of a nerd. Not a nerd, maybe. Anyway, speaking of input limitations for a Cairo proof, what would the data limit be before the prover would start to break down? Could I pass in a 2000 element into the prover for an extreme example? So Cairo contracts are divided in steps. Okay, that's the basic unit of execution in Cairo. And right now there is a limit in the amount of steps that you would need in a block, that you would get in a block. So if your contract or your transaction exceeds that number of steps, it won't be executed. So you won't be able to break down the prover, but your transaction will be rejected from it. You won't want to execute it. That being said, that limit is variable in the sense that we can push it, and eventually we will be able to push it. And once we have put in some optimization that will allow us to parallelize execution, you'll be able to have a much higher throughput. What's the best way to find out about all the useful Cairo libs? I'd say Discord, and we have a Telegram group with people who are interested in coding, and so you can get a lot of interesting Cairo libs there. But most definitely, Discord is where people share their thing. What is the status of the Cairo package manager? Somebody is building it, I think, or somebody is working on it. I was talking with the people from Open Zeppelin recently, and they're saying that they're not ready to push a package yet because the code is not yet production ready. So they want to wait to have something that is safe before actually pushing it to a package manager. So for these examples, for example, they will come in a package manager eventually, but it's not there yet. What does it mean that the importing pattern could be enforced by the compiler? So basically today, right, so here, for example, if I go into token in ERC20, you can see here that you have ERC20 base in ERC up and ERC20. ERC20 base is basically a contract that only implements internal function. None of these functions here are external and are callable. The best practice in Cairo when you're writing a StarkNet smart contract is to have a contract that imports functions from ERC20 base. All of a sudden, all of these functions are reusable in the front, right? And then you write your external functions around it. It's best practice, but it's not mandatory in the sense that if you want to write a contract that has both external and internal function and that imports internal functions from a contract that also has external function, it's possible. Okay. Are loops coming to the language or recursion will be the only way to loop on a collection of value? That's a good question. That's a good question. I know we're working on it, but I don't know how close this is. So for now, recursion is the best. So for now, that's the best practice. I'm sorry. So for now, that's what we do. Recursion. So why is that best practice? I'm going to let you see this discussion here. And yeah, have a read. It's an interesting discussion, and if you have an opinion, please participate. Your input is very valuable. So do let us know what you think should be used to inherit and import functions in Cairo. Okay, so account abstraction, I don't have to spend too much time on that slide. I think we spent some time last time covering it. So account abstraction basically means that every account is a smart contract in StarkNet. Do you know that for now, any contract can be an entry point? So your contracts can receive comments without coming from an account contract. You can send a function call, a transaction, directly to a contract. So this means that if you do that, MSG the sender, I mean the equivalent get caller address will be 0. So that's going to be the that's going to be an issue in your smart contract. Be mindful of that. It will change in the coming weeks, but for now, it's that's the way it is. In IDEs, so what do we use? There are 3 main tools today that are used to develop and deploy smart contracts with StarkNet. The basic one is StarkNet CLI, and it is reused by the other 2 actually. StarkNet CLI is the tool that we publish basically when you install the Cairo Lang package. Then you have a plugin for hard hats that you can use that is based on JavaScript. And then you have another IDE which is called Nile, which is based on Python. And this is what we're going to be using today. All three are in development. They're not perfect. Nile has a few known bugs, so does so does the Hard Hat plugin. So when you identify these, you will need to find a workaround, and you need to find a workaround. Can you repeat why get color address could return 0? It does not appear in Cairo 101 tutorial. Basically, if you send your transaction to StarkNet, okay, let's take a look. Here, let's take the smart contract that is here, right? Here, if I write to it, I'm connected to Argent X, right? And so the transaction here will be sent through Argent X, right? There's something that pops up here. If I open a new incognito window, and let me share my screen again. You should be able to see my incognito window now. If I go on Voyager with this one now, see my Argent X wallet is not connected. If I call this here, the transaction is sent. It's basically sending a transaction without an entry point. And so at that point here, the smart contract will basically receive this function as if get caller address was 0, because it's basically the first function that is sent. This function will fail, obviously, right? It was rejected. But yeah, and that won't stay here forever. Right now, you can call any function without going through an account contract, but soon the sequencer will enforce that your transaction needs to go through an account contract. And we were here. So we are using Nile today. Okay. Oh, these are slides that we presented last time. I'm going to go through them quickly. Brick is a cool game, and we did this presentation with them last time. Now, how do you get to work on that tutorial? So you get the basic gist of it, right? Last time, you remember, there was a set of smart contracts, and you needed to satisfy a few functions to get point, right? If you look here, you get the same functions here: validate exercise and distribute points. So the code you want to validate here is in contracts and in evaluator. You have to imagine this smart contract as a substitute teacher. He will correct your smart contract. It is deployed today on chain. And when you want it to correct your smart contract, first you're going to call a function he has that is called submit exercise. See, it is here. And here you will send the address of a smart contract that you have deployed. Okay. Once you have submitted your smart contract, you will call a function on the evaluator where you will tell him, please correct my ERC721 token, or please check that I have done this thing, or please check that I have done this thing. Okay. So your objective here will be basically to go through all of these functions and figure out how to satisfy the conditions they meet, they require. Okay. There's a long README here, so I invite you to take a look at it. Here, so for the past tutorial, the hardest part was doing the first exercise and getting set up with Argent X. For this one, the hardest part for you will be to set up your environment. And we get a bunch of instructions here that will explain to you how to do that. And I think I'm going to take your questions, and then I'm going to do that with you so that we can check errors that could happen. But yeah, basically, I want you to look at the README. Okay. Here you have a description, a high-level description of what I expect from you. And then you need to go in the evaluator code and figure out what exactly each line does to satisfy it. Okay. Then you write your contract, you deploy it, and you get the evaluator to correct it. Okay, I hope that's about clear. And this mechanism is what we'll use for this tutorial, the ERC21 and another one. So that's the basic gist of it. I think I'm gonna clone the repo and do the first question with you so that we can get started easily. Let me check if there are questions. Nile is much faster than JavaScript. Yes. Argent and OpenZeppelin Smart Wallet have the same interface. Not really, they're a bit different. They use the same basis function to interact with the chain, but the Argent one has what the notion of a guardian, meaning a key that can restore your wallet if you lose your key. Okay, and then 361457 is saying that page of error is my problem. I have no idea how to stack trace means and how to resolve it. That's a good remark. We need to make debugging more clear in Cairo. And actually, we have one feature that came out, I think, a month ago or so, or 3 weeks ago, and that was implemented by one of the developer of the second tutorial that we'll look in a sec. So you'll see how to do that in your contract. Okay, and Philip is asking, for the verify signature function, the wallets are the same. I think they are. The thing is, I'm not sure you can point the Argent X wallet to use a wallet that was not deployed through it. So you'd have to check that. By the way, guys, if some of you are interested in what account abstractions opens as possibilities on StarkNet, this is most definitely an interesting hackathon project. If you want to try to build a wallet where the operator pays for the fee for the user so that people can have free transactions, so native meta transactions, do so. If you want to build a wallet where the key changes every time, you can do it too. Your free Argentex is open source, so you can fork it and have fun with the extension. So this is definitely an interesting field to try stuff for the hackathon. All right, so let's try to do the first question together. So, okay, introduction. I'm going to take it like this. Okay, so this is what I do. Disclaimer. Okay, of course, I'm not going to benefit from here. I mean, I'm going to learn a lot of new stuff, but I'm not going to gain anything of value. Providing feedback, please do this too. It helps us make the system better. Your feedback is, once again, invaluable. Okay, so it has 3 components: an ERC20 token, an evaluator contract, that's a substitute teacher, that's the book where he keeps points, and that's just a dummy token that we'll use for the second part of the tutorial to make payments. Okay, cool. And if I click here, I get to see the code for each. Okay, so, okay, what do I have to do? I have to do an exercise. I code it, deploy, submit the exercise, and then test the function. A few notes. I'll let you list this one. They're not, I mean, they're important, but I'll let you read it. How do I check my progress? Count my points. Oh, okay, so I need to go to the ERC counter. Oh, let me check something. Yeah, so here that's where I check if I have enough points. Actually, I'm going to import this contract here in Argent X so that I know if I have enough points. By the way, yeah, right. So I'm going to add token. I think it's already there. It already exists. I'm going to do it with another account, with this one. And it's already there again. Oh, I've done this tutorial too many times. Oh my God. There you go. Here I have no points. Good. Is it the same one? Okay, it already exists. Good. Okay, so that's however many points I have. So I can see how many points I have. I can also go directly on Voyager. Now, okay, that's a note on transaction status. Good to know. So how do I get to work? Clone the repo on your machine. Cool. So let me check that. I'm going to do a new folder called Showtime because I'm doing this live. Okay, now I'm going to clone the repo. Git clone this thing. Okay, so I'm cloning it. Good. Now set up the environment following these instructions. Okay, so this is a part I don't want you to get smart. Don't go here and install Nile and follow the instructions here. I want you to follow these ones first. Setting up the environment. Okay, so I'm going to do this. Okay, so I don't have Python 3.7. I just have Python 3. That's fine. And I'm going to open the VM. Okay, I have a VM. Oh, actually, I'm going to go into the repo now. Good. So I'm in the VM. Okay, I can install all those things. I know I already have them, but you know what? Do this. I already have them. Cool. Nope, not going to do that. GMP, I already have it. Installing Cairo lang. Cool. Then, or I can do that. Okay, cool. So I've installed Cairo lang now. Okay, now I want to install Nile. How do you install Nile? Okay. Same thing here. Looks similar. Okay. So pip3 install Cairo Nile. Very cool. It's installed. So now, actually, I should test this. Nile compile. Yeah, so Nile is recognized. Good. And now it's compiling all my contracts. Let's see if I'm able to compile. That's the very first step, right? So you clone the repo and you check if you're able to compile everything. If you're able to compile everything, it means that you installed the tools correctly. Okay. As you can see, it takes a bit of time. There's a bunch of code there. So yeah, if Nile works, but the code doesn't compile, it may mean that you have an outdated version of Cairo lang, in which case you need to use the functionality in pip to update it, right? I don't know exactly what is the flag, but that's what you need to do. Okay, cool. So I've been able to install it, clone it. Nice. If you don't want to do that, there's also a Docker here you can use. It works on my computer, so I'm not going to do that, but this should work also. Okay, thanks, Piotr. So pip install upgrade Cairo lang. Okay. Okay, so now I've set up the environment. What do I do? Let's see. Okay, so today we're creating an animal registry. Fun. Animals are bred by breeders. They can be born, die, reproduce, be sold. Okay, for sure. So it's an NFT and we basically deal with animals. You will implement these features little by little. Okay, it's fine for me. Cool, so create an ERC721 token contract. You can use this implementation as a base. Okay. Oh, so this is an example of an ERC721 token I can use. It's actually a front-end contract, right? It's already importing functions. So actually, I could probably just deploy this one as is. I think this is exactly the issue the person has. Yep, that sounds similar for sure. So here, this is a front-end contract, right? It imports a base contract, so I can probably just deploy it. Okay, let's take a look. So in order to deploy a contract, I should put this in the README too, but basically to deploy a contract, you will use Nile deploy and the name of your contract. So here, nope. Yep. Okay, so here's my contract. What's it called? It's called ERC721. So probably if I do Nile deploy ERC721, it should work, right? Should it? Show of hand. Do you think it will work? Do you think it won't? No, it won't. Yes, you're right. It won't work. Exactly. The network is missing. It's going to tell me, well, no, I mean, like, I want to know where to deploy, right? So here it's trying to deploy to do the local DevNet, and I have not set it up. So I'm going to tell him to deploy to Alpha Girly. First, let me check. Are some of you already doing that? Have you been able to install the environment and compile? Are you just looking, or are some of you are doing it in real time? I highly encourage you to do it in real time, because that way, if you have issues, you'll be able to tell us right now, and we'll be able to get you going. Okay, cool. So some of you are good. Okay, so I need to specify the network. So let's see, Nile deploy network alpha girly. Should that work? So here, what is my issue? The issue is that I didn't put the correct name. Okay, something here that is tricky. On Nile, you put girly. In StarkNet compile, the StarkNet CLI, you put alpha girly. Okay, so let's do girly like this. Does this work? No, it doesn't. What is the issue? Here, let's take the error little by little. Assertion error. Expected at least one inputs got 0. What is the deal here? Oop. The deal is the following. Let's take a look at my ERC721 contract. What is in the constructor? It takes 3 parameters: name, symbol, and 2, right? So it takes 2 parameters. Something tricky here, it says it expected at least 1 input, when in reality it expects 3. So don't get too confident with this error. It should be made better, but you need to put 3 parameters. So I'm going to put 3 parameters here. Okay, constructor input. Just a sec. So DC Builder is saying I can compile, but I couldn't deploy because of the parameter requirements for the name of the token. I think I have to convert the parameters to int because it doesn't take X. Exactly. When in doubt, move back to decimal. Okay, so let's choose a name for our token and a symbol. And then here, apparently what this does is that it's sending a token to this person. Okay, so I'm going to create a dummy token and just to create this and then send it to myself. So how do I convert the name to a felt? Name is a string. How do I convert it to a felt? Well, it turns out you have some cool utilities that were written by Luca that should be around here. Felt. It's, I'm in Nile. I'm not in a good repo. Here it is. Okay, so here I have some utilities to convert my things. Here, you can see X to int, string to int. I think Lucas has put some, okay, to convert strings to int, use Python str to int. Okay, cool, let's do that. So Python, it's not here, it's in deploy. No, it's here, actually. What's the stupid thing? String to int.py. What do I call my token? Let's call it, okay, so the name is going to be Henri. And then the symbol will be HENR, because that's cool. Okay, so that's my first parameter. So I'm going to copy paste the comment somewhere because it will be easier for me to deal with. Okay, so how do I give arguments to this comment, really? Well, it's quite simple. I'm going to leave this at the end, right? So I just need to pass my arguments here. What's the first one? Name. Okay. Nope, nope, not this. This is the name. This will be my symbol. And then I want to give it to me. I'm just going to take my Argent X wallet here, right? And then I'm going to convert it to int. So Python X to int. Okay, so that's my wallet in the int format. Pretty cool. All right, so now let's try to deploy this. Will it work? Let's find out. And it's holding my breath. It deployed. Very cool. So I get transaction hash here. I'm gonna go check it. Okay, I'm lazy. I'm just gonna reuse this. Okay, so the transaction was received. Let's wait for a sec. All right. So why is it that in Voyager it's impossible to see parameters of the constructor? Are they somehow hidden in the blockchain? They're not really. But let's take a look when this is deployed. You can actually see them. It's actually a security vulnerability, by the way. When you should have seen that in the last exercise of the first tutorial. See, for example, here. So this is the transaction. So this is something that is a bit. This is something that where Voyager is a bit lacking in terms of in comparison to Etherscan. Which contract is this? Okay, so it's an ERC20 token, right? And it looks like there's only one transaction towards it because there was only one direct transaction toward it. If people interacted with that contract, it went through another account contract. So you don't see all the interactions here. You can probably give them, yeah, this contract doesn't even have events. So you see only the transaction that deploys that contract. And you can see it here, and it says deploy. So if I click here, maybe it doesn't, this one, maybe this one didn't have a parameters. You should have the parameters here, actually. I'm surprised. Okay, so my transaction was accepted on L2. Let's wait for a second, see if it pops up. Okay, so the last exercise could be solved with another call, not the constructor. Okay, let's check. So I'm going to show you a little trick, actually. This transaction here, I can't really have it, but I can have it through the StarkNet CLI. So if I do StarkNet, so StarkNet here will give you the utility to that lets you interact with StarkNet. So if I do here StarkNet, what's this command? It's here get transaction. Okay, StarkNet get transaction, and I put the hash here. Network alpha curly. What does it like? So I need to add hash here before the name of the transaction, right? Here, here you see, I get all the constructor call data. So here it's not hidden. So maybe it's hidden by Voyager for a reason unknown, but it's not hidden here. So you can retrieve it here if needed. Okay. Anyway, my transaction was accepted on L2. It will show up here when once it's accepted on L1. Okay, cool. So now I've deployed a contract. Is that enough to validate the first question? Let's see. Oh, I'm going to check your questions here. Okay, I have a problem. The requested image platform does not match the expected host platform, Linux AMD 64, and no specific platform was requested. So Florian, I think it's good if you go to Discord and ask to Lucas. He will be able to focus more exactly on what is your issue. Xavier is asking, could you show again how to get the third argument of Nile deploy? Yes, for sure. So here, the third argument is also a felt, right? It's an address, okay? It's the address of my account. So I went here in ArgentX, I copied it here. That's the address of my contract here. And I used another utility which is in the repo, which is up here, x2int. And if I do Python x2int and I input my address, beam, I got it. Hope that helps. Then Xan is asking, when using StarkNet CLI, I'm setting addresses directly, for example, StarkNet deploy, compile contract, input, Is this wrong? Should I cover the added to int? Works fine via the CLI. I don't know. If it works, then it means it works. If it doesn't, then try converting it to decimal. That's the part where StarkNet is pretty much the Wild West still. You have to figure out what works and what doesn't work. I got a bit of PTSD of decimal conversion, so by default I convert everything to decimal. But eventually this will change. Right. Okay, so how to send your Argent account in Nile command. 361457, can you be more explicit with your command? What is it exactly you're trying to do? But yeah, and I'll answer. Okay, cool. So wait a minute. I've deployed a smart contract, right? I've deployed an ERC20. Is that enough? Let's see. So what exactly does the evaluator want me to do? I've deployed a contract. Should I get points now? Okay, so I need to submit my exercise, right? What exactly is happening in submit exercise? Okay, so it will get my address. Okay, so submit exercise, I have to call through Voyager. Got it. It will, okay, it will see if my exercise has been submitted before. Okay, so I can't cheat. Okay, well, I'm not here to cheat anyway, but thank you. Then what it will do, it will store in this mapping the address of my solution at the index of my address. Okay, so I have a slot, and this is where the substitute teacher will store my my work, right? And then it will write that this address is already busy. Okay, understood. And then I will validate exercise 0. Oh, pretty cool. And I get point if I submit a contract here. Okay, so I should get 4 points here. Let's check. Where is the evaluator? It is here. Path. Okay, so now I want to do this. Submit exercise, it's here. And I want to send my contract address. Where is it? Ha, so that's the hash and that's the contract. Cool. Okay, let me send it. Okay, hope this works. Sending. Cool. Let's monitor this transaction and see what happens. Let's see our questions. In the meanwhile, in the exercise, we need send accounts. Not sure what you mean. Once you upload this session, could you DM the link on Telegram from my StarkNet section in my blockchain development guide, please? Yep, that's a good question. Actually, I think Encode will publish these sessions soon. I think, Jake, you've published the first one already, right? So yes. Very cool. So, and have you published the second or not yet?
I'm not too sure if it's up yet. We were just struggling to get the slides from Julian, and then it goes up.
Okay, cool.
We got them. It should be up either later.
Wonderful.
Yeah.
Cool. Okay. So this means that I'm speaking for eternity. Okay, for posterity, let's do this tutorial. All right, so the transaction has been received. I hope I will get points. But yeah, I mean, I will get points here because like what's happening is really like there's no check. Oh, let me open this back. If I go back to submit exercise here, you can realize that really there's no other check than whether the address was already submitted before. So for sure, I will get the 4 points. The question is, if I call the first function to actually check my ERC20 here, will it work? So this is where the correction of my tutorial will actually start, right, of my work. So what does it do exactly? Okay, so there's no parameter I need to send. Okay. What does it do? Okay, so it takes my address, and then it instantiates a token ID. So that's token ID 1. Okay, so then it retrieves the address that I have sent. Okay, so it's reading this mapping at index my address to get the address of my NFT. And then Okay, what does it do here? Okay, so it gets the address of the evaluator. And then it will call my contract. Okay, and it will check the owner of token 1. And token 1, and this is the owner of token 1. And then it will check that the evaluator the evaluator is the owner of token 1. Okay, so I need to deploy my ERC721, and token number 1 has to belong to the evaluator. Did I implement that? No, I did not. Okay, so let's check what's coming next. We'll go back to that later. Okay, reading the balance. Okay, so it's reading the balance of me and the balance of the evaluator. And then it is checking that the evaluator has 0 NFTs in the beginning. Okay, fair enough. Okay, I think this was corrected, but still. I think it will pass because I know I corrected this bug in the past. I don't know why it's back here. Anyway, so I can hear Lucas scrambling in the back. Okay, so let's forget this line for now. I'll explain that back after if you're interested. You can ignore these lines for now. So what does it do exactly? It will check that basically what this contract does here is that it will check that your ERC721 is functional. So it will basically, the evaluator is supposed to own token 1, so it will transfer token 1 from himself to your address. And then it will check that balance of was updated for both accounts, and then it will check that the owner of token 1 is now you. Okay? It's basically what it does. And it's a bunch of check. If you inherit your smart contract from ERC721, it should be fine. You can see how we do these lines. I think this is, by the way, one of the most cumbersome part of Cairo yet. What is happening here exactly? Here, it will retrieve, like for example, here, it will read the balance of one person, the balance of another, and then it will compare the balance of the evaluator to 0. And by calling this, so this returns 1 if they're equal and 0 if they're not equal, right? So actually this works. There's no bug. Sorry, I gave you a scare. I should not doubt myself as much. Anyway, so basically what it does here is that since balance of returns a uint 256, you need to instantiate 0 as your uint 256 in order to be able to compare it to the value you retrieved here, right? And to be able to compare it. What this means is that basically with these 5 lines, you're doing something that you would do in Solidity with just like 2 lines, right? You could call directly one contract owner of and require balance. You could require balance of on one contract to be different than 0 and something like that. I think that's something that's a bit cumbersome, but on another note, it gives you more, makes your code more explicit in what you're doing exactly. Okay, so I'm inheriting from ERC721. My code here won't work, but I'm going to try it for giggles anyway. So I've submitted my exercise. The transaction has gone through. Okay, I should have points now. I don't yet. Funny. Yes, I do. Actually, I got the 4 points. I'm happy. So now I'm going to say, okay, test my ERC721. Transact. And boom, here's my transaction. This transaction will fail because here it means token 1 to the person I've passed here, and this person is me. So this won't work. So here I actually have 2 options. What do you think I should do? What do you see as options? Like my transaction here will fail because token 1 on my contract belongs to me. So what do you think I should do? Should I redeploy a contract or do I have another option? Send it back. Yes, that's actually a valid option, Florian. So I can either redeploy a contract or yeah, you're right. Let's try to modify my my contract And I mean, let's try to, let's see. So what is, actually, let's spend some time here and then we'll correct it. So here, what exactly is happening? Which step is gonna fail? It's, by the way, I'm spending a lot of time here. I don't know if that's useful or not. There's another tutorial I want to show you. So I'm not going to spend too much time here, but do let me know if this is too long and you want to move to ERC20. Please don't spare my feelings. Okay, so exercise 1, it should fail basically here, right? So it should fail at this assert. And actually, when you're seeing that here, it's not very explicit, but that's exactly what's happening. An assert EQ instruction failed. This value is different from this one. What is this value? Well, it's probably the evaluator address, and this value is probably my account, right? I mean, if I take a look here, this is my account indeed. So basically it's saying, yeah, your account is different from the evaluator account, so it doesn't work. It doesn't work. So not all error I mean, yeah, not gonna lie, this is not very explicit, but it does give you the reason of your error, right? So if you spend a bit of time here, with time, you'll recognize what these errors are, okay? So, okay, let's try again. Let's modify my my contract so that, I mean, let's not modify my contract. Let's send the token to the evaluator. All right. So where is it? Ding, ding. So my contract. So here, I think, but I'm not sure, the issue we're seeing is that since the transaction that deployed the contract was accepted on L2, which means it was accepted on StarkNet, but the proof was not published yet to L1, the contract doesn't show up yet. So here we have two options. We can wait for the proof to be sent to StarkNet, or we can just YOLO and deploy a new contract. And I mean, yeah, let's YOLO this and just deploy it again and see if it works. I don't want to wait for this transaction to go through. Okay, so how did I do? I deployed a contract here and I've put my address here. Okay, so if I just take the evaluator address and mint this token to him when I deploy, this should work. All right, so I'm going to take his address. I'm going to convert it again. X2 ints. Okay, let's try that. And then I'm going to deploy it again, submit it again, and then we'll be good. All right, this is what I need. This is my command. All right. Deploying. And off we go. My transaction hash, I'm going to check here, just, see if things go well, if it fails or not. So that's my contract here. All right, so now I just need to say, hey, evaluator, here is my new contract. Nope, that's not what I want. That's not what I want either. Ding. Nope. Okay. Here's the evaluator. Ding. So now I'm gonna do submit exercise again, right? So submit exercise is meant so that you can call it multiple times. So you can try things. The objective with these tutorials is twofold. The first one is that you get immediate feedback as to whether your code works or not. And for some tutorials, I would say, hey, it's all new, so if it fails, maybe it's not your fault. But these ones, I know for a fact that some people finished it. So if it doesn't work, balls in your court, guys. So please, you can ask questions for sure, but it's not my fault. Anyway, okay, my transaction was sent. And now if I call test ERC721, this should work. Let's see. Anyone else gets command 9 not found after pip install and wide inside Python environment? Are you in the same folder where you installed it? I don't get that GPIC713. Can you explain, Florian is asking, can you explain where you found the utilities for conversion to failed, please? Yes, they're at the root of the repo. They're here. Okay. GPIC713, can you yeah, check on Discord and Lucas will take a look if he's still here. Okay, so my transaction is received. Do you think I can try and send my transactions straight away? Yeah, actually, I wanted to show something. It went too fast. It's okay. I'll show you another easy bug to later. Okay, so I've submitted my ERC721. Now this should work, right? Token 1 belongs to the evaluator. Token 1 belongs to daddy. There you go. So let's see if this works. Dun, dun, dun. The frills coding live. Anyway, something I wanted to show you is the following. Like if I click here again, actually, will that work? Let's try. There's no point in doing that. No, but actually, this one is still in receive. Let's try to submit another here address. I mean, a new address. So this should fail, right? Because I've already submitted it. But I think it would fail. It will fail for another reason that I want to show you, right? So here I called again submit exercise. While we were waiting for this transaction to be processed, I submitted my exercise again. And so this should fail because if you remember correctly, there's something to check that there's no code duplicate. And since I've already submitted this code, it should fail there. But I think it will fail somewhere else, and I want to show this to you. Okay. Okay, so let's wait for a bit. By the way, I'm seeing this here, which is not great. If you take a look here, this time is quite long. I think that Voyager is taking some, lagging a bit behind StarkNet. So either it means that StarkNet is slow or that the sequencer is slow, or it means that Voyager is slow. So please be mindful that this is still alpha software and sometimes things get slower, especially when you get a large number of people trying new things. And turns out today was a special day because a new app was released on StarkNet. And it's, I don't know if some of you have seen this. Yeah, this one. Game of Life Infinite. So Game of Life, basically. So this is an app that lives on StarkNet, and it's a StarkNet take on a very old video game. That's one of the first video game that was created on computers, and it's basically a game where, according to specific rules, you get forms of life evolving in a random fashion. And basically, what it does is that at each step, it will calculate what is the next iteration of this. What is the next iteration of this game? And this is something that is just not doable on Solidity. It takes way too much computing power to compute what is the next step of that. And yeah, that's just an example of what you can do with StarkNet. So here you can see the form of life evolving. And I have just pushed it one step further. And part of the reason why the network was slow today is probably because of that, because you get a lot of people trying this at the same time. Anyway, it's kind of mesmerizing, right? Do you know where it's going to go? Well, evolve it and find out. Okay, let's go back to our transactions that should have failed. Yes, it worked. Okay, so this transaction went through. Good. Now, okay, so Miguel is saying StarkNet is slow. I'm doing the 101 at the moment. Yep, sometimes it's a bit slow. And Florian is saying, is there a reason we can only see some things with Voyager? For example, the events can only be seen in L1. Are there reasons for this? I don't have specific reasons. I think these are design choices taken by the Voyager team. But I think that if you think some features are missing, you can go on Discord and ask them. They're very responsive and they'll be more than happy to have your feedback on it. Okay, so see, my transaction went through. I got my point. So I validated the first exercise. That's very cool. Now I'll be able to do all the following questions. Before we move to the next tutorial, I wanted to show you this. See, it failed. So remember, there was one transaction that I had sent, and it was in status received. Then I sent another transaction. It should have failed here exactly. Has solution been submitted before is 1, because I had already submitted my exercise, and it should be 0. But if you took a look at the error log here, what is exactly the error it's saying? 3 is different than 2. What is that exactly? Well, I'm going to give you the key here. If some of you have dealt with Ethereum systems at scale, this is nonce hell. Basically, the way you avoid what we call replay protection on Ethereum is to have a nonce in your transaction, right? If you go look in MetaMask, there's a nonce associated with any transaction. And it's basically what ensures that your transaction can't be replayed, reused. Transactions in StarkNet don't have nonces, but smart contract accounts do. So your Argent account has a nonce. What happened here is that basically, while my transaction here was pending, when I sent another transaction, the second transaction got assigned the same nonce as the one before. And so hence why I said 3 is different than 2. It expected nonce 3 and it got nonce 2. Okay, so where am I going with that? Basically, if you try to execute too much transactions at the same time, sometimes Argent doesn't increment nonces correctly, and you get this kind of errors. So this one for sure, if you spend some time on this tutorial, you're going to see it sometimes. So be mindful of it. Okay, so I think I've explained the ERC721 contract. I'm going to move to the second one unless you have more questions. And yes, yeah, let's do it. Let's present again and then show the ERC20 now. So it's here. So this one is brand new, and the cool stuff with this one is that we could remove this because it's now officially launched. There were 3 of us collaborating on that, and I want to send here a big thanks to Florian Charlier, which you can find here on Twitter. He's called Travis. I mean, his pseudo is Travis, and he's the one who developed most of the tutorial. And he did a great work, and you're going to be playing with his work tonight. So a big round of clap to Florian. And my point here is that if you want to collaborate to our ecosystem, please do. We're more than happy to have a contribution such as that. If you have good ideas for tutorials or support to teach people how to deal with StarkNet, please let us know. I think this is our big challenge, getting people to understand what StarkNet is and how to use it. Okay, so same concept here, right? I mean, it looks a lot like the other. What do you do? Okay, so this one is focused on ERC20. So the ERC20 token standard, okay. So it's going to teach you how to deploy an ERC20 on StarkNet and customize it. And I did this tutorial back in 2018 where ICOs were all the rage. And this tutorial will make you basically do an ICO on StarkNet. So actually, I'm not going to spend too much time on it because if you manage to go through the logic we just did on ERC721, this one is very similar. You get a contract here, you get an evaluator, and same thing as before. You get a function called submit exercise, and you get to submit your work. This tutorial has actually two parts. So if you're familiar with ERC20, who here is familiar or somehow familiar with ERC20? I don't know if how familiar you are, but basically there's two layers of complexity I see in ERC20. The first one is actually understanding how you keep track of balance and use transfer and deploy it and stuff like that. And how you customize it, you can mint it and burn it. And then the second layer of complexity is how you manipulate ERC20s from contract. How do you use transfer from? How do you deposit ERC20 tokens in another contract? So for example, when you're using a DeFi app, I don't know if some of you have already used Aave or Uniswap or Compound, all of these apps. You have to do two transactions to deposit tokens in them. One is the approval and one is the actual deposit. And there's a reason for that. And the reason for that is transfer from. And so this tutorial really shows you two things. One is how to deploy your ERC20 and customize it. And the second one is how you integrate a contract with ERC20. So there's two parts of it, one in which you will have to deploy an ERC20 and one in which you will have to deploy a contract that manipulates ERC20. And that's why on this tutorial, you actually have two functions. One is submit ERC20 solution, and the other one is submit exercise solution. So this one is when you create your own ERC20, and this one is when you create your contract that manipulates ERC20. And same thing here. So Florian did a bit of cleanup. So here, instead of having validate and distribute in two functions, he made one single function called validate and distribute points. And here in this one, you get 5 points, which is cool. So, and then it's just basically the same, right? You just go back up and you figure out what is expected of you. So a small, actually, I'm gonna do it because there's something important here and there's the same logic elsewhere. I'm gonna take the questions. Is there a preference to which one we should start with? Does it matter? No, it doesn't matter. You can start with whichever. Both of them will give you points, so it's worth checking. And then the second question is, what is paying is StarkNet? Is it public somehow? What is ETH in StarkNet? Sure. So StarkNet right now is in alpha and it's maintained by StarkWare. You're not paying for fees because we haven't deployed this yet, but this will change in the coming month. So very soon you will be paying fees in Argent X with your wallet in ETH, and that ETH will be an ERC20 on StarkNet. So there will not be a native currency like ETH in Ethereum. ETH will be the default payment for fees, but it will be as an ERC20. And right now, StarkWare is paying for StarkNet while it's still in alpha, but soon you'll pay for fees, and eventually when there will be fees and decentralization, then the network will be able to sustain itself. Okay. So I'm actually going to do this tutorial at the beginning because there's something here that I want to show you. Okay, so let's clone it. Let's go inside it. I already have the VM. So let's try to compile Nile again and see what happens. Okay, Nile is here. It should compile. Let's let it brew for a while. So we would have to deposit ETH in a contract on Ethereum mainnet to get some on StarkNet. Yes, that's what will happen when you need to bridge funds. This will we actually have a bridge with pending deployment. We will deploy it once we have fees. So I think the ETA for this is, I don't want to say stupid things, but I know it's in the order of, if it's not in the next 2 weeks, it's in the next month or so. Okay, my contract compiles. Let's take a look. So first exercise is assign rank. Okay, so I'm actually not going to do it like if I were discovering the exercise. I'm going to explain this to you. So here, when I test your ERC20, I want to make sure that you're able to deploy an ERC20 and customize it. This means having a specific ticker and having a specific name and having a specific supply. So in order to do that, I want you to have a specific supply assigned to you, right? This is what I'm doing here. I'm reading the supply that was assigned to you and the symbol that was assigned to you. Then I'm going to read what is the supply of the token you've deployed, and I'm going to read what is symbol of the token you've deployed. And I'm going to check that they're the same, okay? So in order to get an assigned supply, you do this here. It's called assign rank. You don't need to do anything to do that. You just need to go to the evaluator and then get a rank. So we're going to do this together. All right. So the evaluator is here. Okay. I'm going to read the contract and I'm going to see what is my assigned rank currently. So, okay, my assigned rank is 0. 0, right? I haven't called assigned rank yet. So my assigned rank is 0. So I'm going to say, okay, so give me a rank. Okay. Basically what this does here, assign rank, is that in the evaluator, there's a there's a function called assign rank to player, right? And in the evaluator here in X0 base, let's take a look. There's a store where I store attributes. And these attributes are, so there's 2 indexes in order to have just one storage variable. One is the column and the other is the rank. And basically it also has a variable that is called next rank. Every time somebody calls next rank, I'm going to increment next rank and assign the current rank to the person calling it. And in the storage variable here, in the random attribute storage, there are 100 values. So each time somebody calls, the selector will increment by 1. And so this random storage, which I've populated at deployment, will increment each time. And so basically, this means that I mean, there's 100 values. You get 1 rank in the middle, and yeah, that's your supply and rank. So here, I required a rank. It was accepted. Let's see what my rank is. So what's my rank? My rank is 2, so I'm player number 2. Very nice. I wonder how many people will have played by tomorrow. And now I can say, okay, so what is exactly the ticker and supply you're expecting of me? I'm gonna say 2. Okay, so this is my ticker, and this is my supply. Okay, so this is how many points. This is how many tokens I should mint in my ERC20, and this is the ticker I should play. I should give. So here in my evaluator, let's go back here. X1, X2. So it will read the supply, read the ticker, verify that they're the same. Cool stuff here. You can see here there's an assert is equal 1. This assert has an error message. This is a new feature that was shipped not so long ago. And actually, let's try it, you know. I'm going to deploy a bad ERC20, and then I'm going to deploy a good one. So what else does it do? It basically checks that the evaluator has 10 tokens. Or does it? No, it doesn't even do that. It just checks that the approval function and the allowance function works correctly. Okay, so here I'm just checking that your token is as implemented the approve and allowance function. Okay, so I just need to deploy an ERC20. I can do that, I hope. So let's try that. Let's see. So in the token here, ERC7, ERC20, there's a bunch of them. I'm going to take this one. So what's in the constructor? There's an initializer, name, symbol, initial supply, and recipient. Okay, so if I call the constructor here with the proper supply and the recipient doesn't really matter, but if I do with the correct name and symbol and supply, it should work. So what I'm going to do is I'm going to deploy one here with an incorrect supply, and we're going to see if the error message pops up nicely, and then we're going to do one correctly. So I'm going to reuse the command that is here. So this one, I want to deploy this one, DTK ERC20. What are the parameters that I want to use? So I want name. What is the name that it gave me? That's the ticker. I'm going to use the ticker for the name. It's the same. Ticker symbol, right? Initial supply and recipient. So here, see, initial supply is a UN256. If you remember correctly here, yesterday we said UN256 are composed of two felts, because a felt goes up to 2 to the power of 251, and a UN256 goes to up to 2 to the power of 256. So we need two of these. So this means that here in my constructor, I'm going to have to pass two felts. And I'm pretty sure I'm going to have to pass the lower one first. So here, when it says supply low 16 and supply high 0, this is the one I should pass first. So I'm going to pass this. I'm going to put here a 2. Okay, so this one won't work. And then the recipient, I'm going to put the evaluator. Doesn't really matter for now. Actually, I want the token myself, so I'm going to keep them for me. Okay, so here I'm going to do again x2 int. Oh, we don't have it here. Nope, we don't have it in this repo. Okay, so I'm going to use the one that's in the other repo. That's my address. Stack. All right, so this should deploy, but it won't validate for my exercise. And this should deploy, and it should validate my exercise. What are the differences between the different ERC20s in the repo? Well, go and find out. Now I can explain quickly. So this one is the one used to count the points. And if you take a look, it can't be transferred because I don't want you to collect points on various accounts and then transfer them. So it has a function called is transferable. And by default, it's not transferable. So you can't transfer them. And then this is an interface, this is an interface, this is an interface, this one is the base, and this one is the dummy token. So the dummy token has a function here called faucet, which will basically give you 100 tokens. So it's one made for you to play during the tutorial. So it's a custom one. So that's an example of the faucet and how you can use Mint. And hint, hint, you'll have to use this in the future. Okay. All right. This one I'm not sure I deployed yet. Okay. All right. So this contract, I will submit it, but it won't work. But I want to test the error message. So submit ERC20. Boom. All right. So this transaction will work, of course, because it's just submitting the exercise. But this one here won't. Once this transaction has gone through, this one won't work. Florian is asking, if I remember correctly, shouldn't we use the player address, not the rank, to get the expected ticker and supply? I mean, I use the rank, so it appears to be working. I didn't get an empty value, so it appears to be working. Actually, good question. Do we have to use the player address or the rank? Let's find out. Let's go inside the evaluator. So here, if I look here in read contract, so read ticker and read supply, what did they give me exactly? Read ticker. It takes the player address here. So yeah, it's actually supposed to be the player address. Yeah, that's weird. Did I do that? Funny. I have no idea why this is doing that. It shouldn't. Okay, so this won't work. That's interesting. I have interesting. I have to note this in the back of my head. All right. So, all right. So I should use my address here to get the player to get the ticker and the supply. So these are the actual ticker and supply I should be using. So this is the ticker and this is the supply. Looks weird because it's well formatted. It should, I mean, if I say here 2. Food for thought. Hopefully we'll still see the error messages. Yeah, you're right. Let's actually go there, write contract, test ERC20. So my transaction has gone through. Now if I test this, okay, we interrupt this broadcast for a public service announcement. Just a sec. And we're back. And the transaction has been received. It should fail. Oh, this one is nice. It's good. We see it here. All good. And this one should fail. Now it should fail because the supply is not correct. This supply should be correct. Then I'm going to register that contract. I don't want a nonce error, so I'm going to wait this here. So sometimes in the evaluator, I want you to implement some functions in your contract. And for that, I've defined an interface. Actually, you can see it here. I think it's this one. No, it's this one, ERC20 solution. So sometimes, for example, so as I mentioned, this tutorial wants you to do an ICO. if you call IERC, and in order to do an ICO, for example, you want to do access list or whitelist. I want you to implement these functions in your exercise. So I want you to have a function called allow list level. And that's why I'm using this interface. This interface is defined here. And so basically, these are all the functions that your token will need to implement along the tutorial. So be sure to check this. This is basically the prototype you need to implement. It needs to be called get token and return on you into 256. Okay, so that's probably something we should make more explicit. But yeah, your token needs to implement these functions. All right. And there we can see it. The error message. Supply does not match the assignment's request. Okay, so it works. We know the error message is working. This is nice. Use error messages, guys. It's more efficient. I'm actually happy. First time I see it. Oh, just a sec. So Sean is asking, has those the approvals work on ERC20 contract for transfer from? Can you give an ADI blanket approval to move all your money, or do you need to give incremental approvals? That's a good question, and I'm not sure. To be honest, I have not looked in detail how it worked. Let's take a look. So let's see. When I use transfer from here, what does it do? Here it will, so here basically it means that when you use transfer from, it will reduce the allowance each time, right? So, so yeah. Okay, so I think I understand your question, Xan. You're saying, do we need to do like we do on Ethereum today and say, okay, spend all of my money and then you just have to do one approval? I think that's what you're asking, Xan. And yes, and the answer to that is actually pretty cool. Why do you do blanket approvals at all on Ethereum? And the reason is it's cumbersome. It's long because you have to do 2 transactions, and it's expensive because you have to do 2 transactions. The thing is this, and the idea is that but it's better in terms of security if you do various approvals, because then you're sure that if the contract is compromised, then you only, I mean, if the contract is you need to do it twice. It's better in terms of security, but it's cumbersome in terms of UX. The cool thing with StarkNet is that since we have account abstraction, we can basically, you send a transaction to your account contract telling him execute this payload. Well, we have implemented a feature called multi-call where you can say execute this list of payloads. And so you can, if you want to interact with your contract and have more granularity with approvals, for each time you interact with the contract, you can have both the approve and the transfer from in the same transaction. And second, since you have that, it means that you can have custom approves for each transaction. So it's much better in terms of security. Okay, sorry, I took a bit of time to explain that, but happy if it helps. So yeah, here the allowance is adapted. Okay, let's go back to here, and then, so this transaction was done. Now let's see. Do I get my points? Did this work? Let's see. So I probably should have gotten some points here. Oh, I didn't have the token here. Let's do it right now. Oh, this didn't work. Okay, so now I'm sad. I want to do this. I want this exercise to work. All right, so let's try again. What's my ticker? What's my supply? All right, so it's this. This should work, right? I mean, it's the same, right? This should work. The ticker is correct. Okay, let's go take a look at my contract. First, let's check if my contract was indeed. Let's see if my contract was recorded. So since there are two parts here, I'm doing part 1. So this should be my address, right? Okay, it's correct. It's indeed this address. Okay, so that's my contract, right? So now what is the total supply? 16. How come? Because I didn't deploy it correctly here. I didn't copy paste the proper line. Silly me. Okay, let's copy this. Do it again. Okay, let's try and correct my my exercise, and then I'll leave you to finish the exercise. Florian, I know you're here. How many points do we have available for this exercise? How many points should people try to get? If you can write it in the chat, that'd be great. Actually, you know what? We can count them. Let's take a look. All right. Okay, so here there's 1 point, 2 points, that's 3, 2 points, that's 5, 4 points, that's 9, 5 points, that's 14, 2 points, that's 16, 19, 21, 21, is it? Yeah, 21, 22, 23, 25, 29, 31 points. Good. And let's see. Okay, so 36 points. How many points are required to get the prize? The real prize is knowledge and the friends you made along the way, guys. But yeah, for sure, if you get 2/3 of the points for the 4 workshops, I get a workshop. And you know what? If you find me in real life, I'll buy you a beer. There, I said it. Is the StarkNet JS workshop included or just the Cairo one? No, the StarkNet, so the StarkNet JS is not automated, so it's harder to correct. No, so there will be 4 workshops. The 2 of tonight, the 1 of yesterday, and in 2 weeks you will have one with L1, L2 interaction. All right, and it has been accepted. I got my points. I got my points. My kid is crying because he is stuck on the toilet. Anyway, I think we're done for tonight. I've shown you both tutorials. You should have all the ins and outs, and you should be able to work by yourself. As you know, you can find me on Discord. I hope you learned something tonight. Can we make a quick show of hands? Who learned something tonight? Can you make the reaction with your hand like that? That would be very useful. Good. So, guys, with that, I'll say thank you. I'll see you in a week. So next week we'll have actually a really cool invite. A really cool guest is Sean. He's working on Oasis, which is an NFT marketplace. If you go through the ERC721 tutorial, you will use Oasis. So yeah, take a look there and mint some NFT on StarkNet. Jake, I don't know if you want to conclude that. Other than that,
No,
I'll give it back to you.
Nothing to add. Yeah, thanks for coming, Henry. Thank you so much. And thank you for everyone that stayed on this late. Cheers, guys.